Hello friends, this is Daniel from Moralis, and today we're going to do something very interesting. I have prepared for you a little introduction to DeFi and how to deal with DeFi protocols programmatically. For this, we are going to work in a scenario, and for this scenario, we have prepared a little lab that you can follow and reproduce by yourself in order to learn how to deal with this type of DeFi transaction. So let me start by this scenario. The scenario is that we have this opportunity here that is an arbitrage opportunity where we can gain 5 wrapped AVAX tokens if we execute this arbitrage. Might be something that is in a liquidity pool, in a DEX, whatever. Right now, I'm just mocking this in certain contract that I have for this scenario, but this is something that might happen in the real world. In order to take advantage of this arbitrage, we need to have 100 wrapped AVAX tokens. And if I go to my wallet here, you will see that I don't have this amount of WAVAX tokens. I have only 3.6, which is way less of what I need. If I try to take the arbitrage right now, then my MetaMask is triggering, but it's telling me that there is an exception thrown in the contract code. Then, what can I do if I discover this arbitrage opportunity and I want to take it, but I don't have these funds? As in the fiat world, I could take a loan in crypto, but for that, as in the fiat world, I will need some collateral. And let's say that I don't have enough collateral to support this amount that I need to borrow, which in fiat, it's around $10,000. And let's say that I don't have that amount. I have another option, which is a flash loan. And what a flash loan is a loan that you take, but that you return in the same Ethereum transaction. So what the protocol does internally is that it will transfer some tokens to you, but it will have some conditions in its smart contract where if you don't return the funds in the same transaction, is not going to happen. So this gives you some properties that don't exist in the fiat world. In the fiat world, the lender doesn't have a way to know that you are going to pay him. So he will ask you to have either reputation or assets to back up the loan that you are taking. Since in the blockchain, he can actually confirm mathematically that you are going to pay because you are paying the same transaction, then he can just lend you any amount with the assurance that that will come back to him. Service of a flash loan is not free. The flash loan protocols, and AAVE is one of the flash loan protocols that exist. It's a very popular DeFi protocol that offers flash loans, will charge you a small fee of 0.09% of the amount that you flash loan. So that's basically free money for AAVE because they know that they are getting paid. So as you can see, this is quite profitable for the lending platform, and it's also convenient for the user. So it's a very good business for everyone. Now, let's talk a little bit about the flash loan itself. So AAVE is one of the protocols that offer flash loans. And let's check if they have enough liquidity in the liquidity pool in the testnet of the Fuji Avalanche testnet to provide me with this liquidity. There are exactly 100 here. I will explain to you why that's exactly the liquidity that appear in the liquidity pool later on, because this is kind of part of our mock scenario. But for now, let's say that we have 100 AVAX or wrapped AVAX available in this liquidity pool. AAVE is going to charge us for this service, right? Like we have to pay the loan in the same transaction. If we check our arbitrage here is 5 wrapped AVAX. So the amount that the liquidity pool is going to charge us for the flash loan is reasonable. So we can proceed and try to do it. And let's just do it right now. So For this, I will need to know what is the address of my flash loan contract and transfer some wrap AVAX to it in order the contract is able to pay for this flash loan. So I will copy this address here. This is an address that I will tell you later on when you deploy your contract where you might find it. And I will transfer this little amount of AVAX or wrapped AVAX to the contract in order I'm able to take advantage of this opportunity. 1 AVAX should be enough. And we are going to send that to our contract. We have transferred the amount of WAVAX to pay for the flash loan to our flash loan contract. And right now we can take advantage of the arbitrage. So for this, we have a little front end for our flash loan. It's convenient if you are doing it like I'm doing it right now. So I want to borrow 100 in the flash loan and I will just get everything going right now. Execute it. My MetaMask is kicking in. This is coming up right now. So with my MetaMask kicking in, I will confirm this transaction and flash on this amount of WAVAX. We've got the transaction hash here that the operation was concluded with. And with this transaction hash, we can go to the Snow Explorer of the Avalanche Fuji network, which is kind of like Etherscan. And we are going to search for that transaction. And you can see here the trace of that transaction. So first, this is the liquidity pool in AAVE, 100 wrapped AVAX to my contract. This amount was deposited in my contract to take advantage of the arbitrage. I didn't actually deposit it in the arbitrage because right now the condition in there is just that I have to have it in order the arbitrage contract let me take the amount of the arbitrage. But in the real world, it will be like this, passing the entire amount to this and then getting it back and then just taking the profits, right? But here is just more straightforward. I just have the profit. So this is the 5 RAT AVAX that were in this arbitrage contract were transferred to my flash loan contract. This is something that is happening internally in the liquidity pool to pay for some services there. That's internal to the AAVE protocol. And then this is the amount that I have to pay back to the liquidity pool. So as you can see, everything executed correctly. If you see the liquidity pool has more wrapped AVAX right now because they charge me some money for the flash loan. If I refresh this screen, this is gonna disappear because there is no arbitrage there. I already took it, so this one is 0. If I go back to my wallet, you can see here that my amount of WAVAX is the same. And that's because the WAVAX that I took from the arbitrage is in my flash loan contract. But we are going to clean it right away. So this is the functionality to clean it. And we're going to withdraw everything that is into that contract regarding this token that we took the arbitrage with, and we are going to get it back. After the operation was concluded, we can see that the withdrawal was successful with this transaction hash. So we're going to go back to our wallet. And here in my wallet, I can see that I have in WAVAX the amount of 8 tokens right now. So this is the arbitrage that I took and I earned from this operation. Guys, we are going to learn how to build a flash loan contract that can take advantage of the AAVE protocol to perform this kind of operation. It is there, it is open source, but remember, using this in production is on you. You have to check out that all the code checks out security-wise and performance-wise to what you want to do. Remember that you have to calculate all the fees for stuff like this and the gas as well, because all of those expenses have to be offset by the arbitrage that you are earning. We are going to start reviewing the code. So let's talk about the lab. What you will need to complete the lab. We are going to talk a little bit on how does it work, and then we're going to start reviewing the code. Now, what you will need are three things. You will need to download the code, a Moralis account, and some testing AVAX tokens. So let's cover those parts right now. First of all, we are going to download the code. This is the link of the GitHub repository that you will need to clone. This is going to be in the description of the video, and it will have everything that you need, even some extra information that you will be seeing later on. So for this, you will just do git clone, paste the URL, and then enter, and that will clone everything. Now, after you have done that, you will go to your favorite code editor or text editor, and you will open the folder that you just cloned, and that's it. You will have some code here that we're going to review later on, but I want you to go to reference and important information. We are going to need to interact with the Avalanche network, and for that we are going to get to Moralis.io to connect to the network first. And if you don't have an account, you can sign up totally for free, and if you already have one and you are part of the community, just log in with your credentials and you're going to see your servers. Then if you don't have any server, you will have to create one and take note of your credentials, the server URL and the application ID. We are going to use those later on to build the UI for the lab. And right now what we're going to copy is the speedy node. We are going to go to endpoints, Avalanche, and you're going to copy the one for the testnet here. We are going to copy that one because we are going to use it with some other information that we are getting from here. With this information that we have here, that is the network name, the RPC URL, which we just copy from Moralis, the chain ID, the symbol, and the block explorer to add our Avalanche Fuji network to our MetaMask. I already have it, but if you don't, you have to go to add network, and this will open this form that you will have to fill with all the information that it's in the code in the Visual Studio that we just saw. So once you have that, you are going to see your Fuji network here already installed. And here in my MetaMask, this is actually AVAX, but it's showing as BNB because of some bug that MetaMask has when you are dealing with a lot of networks, and it doesn't really get the native token correctly all of the time, but that doesn't really matter. Just mind that it's AVAX. Now, when you have completed the previous step, we can go to the next part, which is being able to get some testing AVAX tokens. This link is the Avalanche Fuji faucet. Here in this faucet, you just paste your address, you complete the CAPTCHA, and you request the AVAX that you need to get. For me, it took me a couple of days to gather a lot of AVAX to be able to have the liquidity of 100 wrap AVAX that I'm getting in the flash loan for the scenario that I show at the beginning. But you can do it with way less, it's the same. So don't worry about that. I also left the liquidity there, but I cannot guarantee that that 100 of liquidity will be available for you when you try. So for that, you will have to go to the flash loan protocol in the staging server and check out what is the liquidity currently. Now, there is another thing that I want you to check, which is after you get some AVAX token, you will need to go to the other link that is here, where you need to wrap your tokens. Ethereum is a native token. AVAX is also a native token. But all the other tokens that you interact with in DeFi are not native tokens, are tokens that are ERC20 compatibles for the platform that you're working on. So in order to use the native token in a DeFi protocol, you have to wrap it. That is putting it in a smart contract that will return an ERC20 representation of the native token. And that's what wrap Ethereum is and what wrapped AVAX is. So after you went to the faucet, you have gotten some native token, but you need to have some WAVAX to allow you to pay for the flash loan, because the flash loan will be in WAVAX. It's not going to be in native tokens because what we talked before, the DeFi protocols only work with ERC20 compatible tokens. So for this, I could go here and connect to Web3, and I will connect my MetaMask. My MetaMask is connected, and I could deposit some AVAX token in order to get some WAVAX back. So let's say that I want to have 0.2. My MetaMask is going to pop up, and this is 0.2, and I'm getting that. Now let's check in my wallet. You see here my balance of this token decreased, but my balance of WAVAX, which was 3.6, increased to 3.8. So after that, you have your WAVAX token that you might need. I will recommend that from the faucet you will get like 10 each time, so you will need around 5 WAVAX for the lab. So wrap that amount and then you'll be golden. Having done that, we can go to talk about how the lab works. The scenario and the lab have 4 main components: the mock arbitrage, the flash loan contract, the account that you are using, and the liquidity pool in the AAVE staging server. So for the mock arbitrage, this is just a mock contract that is faking the possibility of having an amount of certain token deposit to your own account only if you have another certain amount of the same token. This could be different tokens, but to keep it simple, we just use the same token, and that's the wrapped AVAX token that we were talking before. So there are 2 main variables in that token: the arbitrage amount, which is nothing more than the amount of WAVAX that is deposited in the address of that specific contract, and the required funds that you need to have in order to withdraw this amount of token through a function. And these required funds, you can set it up at deployment, but also you can change it after the contract is deployed with an only owner function. This is just a mock for this scenario, but this is in real life something that might have appeared in a liquidity pool or in other type of DeFi scenario where it's not actually something that you are setting up, but it's something that by the behavior of the protocol, it appeared and can be taken advantage of. Then you have the flash loan contract that will provide you the funds that are required by this one. And these funds are going to come from the liquidity pool. The flash loan contract will need to have some wrapped AVAX because that's the coin that we are borrowing, and we have to pay the commission in that same coin. So we have to have some wrapped AVAX in the flash loan contract, and then this flash loan contract will take the funds from the liquidity pool, call the mock arbitrage function, and this arbitrage function will check that the flash loan contract has the required funds, which will be the case because it was borrowed from the liquidity pool in that specific amount. So the arbitrage amount will be transferred to the flash loan contract, and then the flash loan contract will pay the loan back along with the commission, and that's the reason we have this wrapped AVAX here. After that, all the flash loan functionality would have been concluded, but the funds of the arbitrage are still in the flash loan contract, and this is not a good practice. We have to empty that. So for that, we need to have some function in the flash loan contract that will allow us to withdraw. Now, in your account, you will have to have wrapped AVAX and AVAX token. And why? And you will need to have wrapped AVAX to fund your contract in order it can pay for the flash loan. And you will need AVAX because the way to get wrapped AVAX is by wrapping the AVAX token. But also, we will need this because the liquidity pool is not very liquid in the testnet. I left 100 WAVAX here for anyone to use, but those 100 AVAX might not be available for you, and I don't know what is going to happen in that liquidity pool, right? So you might have to provide your own liquidity. By getting AVAX from the faucet, you will have possibility to go back to the AAVE staging protocol and deposit liquidity in this liquidity pool to recreate the scenario. And that depends on how much required funds you set up here. You don't have to wrap it because the AAVE protocol will wrap these AVAX by itself. Though in the liquidity pool is wrapped AVAX, what you are depositing is just pure AVAX. AAVE is taking the functionality of wrapping it up by itself for you. So this is basically the mechanics of what we are doing in the lab. Now we're going to go to check the code. We're going to check the contracts first, and then we're going to check a little bit the UI that we built, that thanks to Moralis is very easy to build and makes this quite convenient. So guys, as you know, we cloned the GitHub repository that was in the repo to our local environment, and here we are in our code editor. We can see that there are several folders there. We have the front end folder, which we are going to review later on. It's our front end that we developed with Moralis very easily. We have references, which contains our library of important information. This is something that we are going to use later because we need it for the configuration of our contracts when we deploy them. And then we have our Solidity folder. And this Solidity folder is the one that we are going to start checking out right now. It has several files here, but the ones that are important are the one that is called mock arbitrage and my flash loan. The other one are libraries that I will not explain in their totality because those are standard libraries. I will just explain the flash loan receiver base, which is an abstract contract from which we are going to inherit in our flash loan contract. But that's the only one of the standard contracts that I will explain. I will get into more details in our mock arbitrage contract and obviously in my flash loan, which is the beef of what we are doing. So for the mock arbitrage contract, what we have here is that we are inheriting some libraries. For this one, we are using the compiler version 0.6, and that's because AAVE version 2 is in that compiler and we have to make it compatible with that version. Now, if we go to our contract itself, is very simple, is not doing a lot. We just have two functions in this contract. We have one function that is called take arbitrage, and we have one function that is called set required funds. And what set arbitrage is doing is recording who is the taker of the arbitrage. It's checking what is the balance of the person who is trying to take the arbitrage, and then check whether the balance of this person in the token that we are working with, which has to be sent along a call to this function, it's greater or equal than the required funds that are defined by this mock arbitrage contract. If it is not, it will revert with the message not rich enough to take advantage of this arbitrage. If this actually is the case, the taker has enough balance to take the arbitrage, then the asset balance, which is defined as the ERC20 balance of the token that was sent in the function balance of this contract, that balance is going to be transferred to the message sender or taker. Actually, we have to change this taker. The other function that we have here is set required funds, and this one allows us to set how much of a required amount we are going to require for arbitrage takers here. And this is something that we set when we deploy the contract, but we are just given this function there if people need to change it after the contract is deployed, because for this lab, the amount of funds in the liquidity pool might vary. So you can have flexibility to set it one time when you deploy this mock arbitrage. But if you want to do another practice round and there are not a lot of funds in the liquidity pool and you don't want to wait for the faucet to have enough funds to provide your own liquidity, you can just change this. I want to remind you guys that this lab is a mock scenario. So you are providing most likely your own liquidity because in the liquidity pool, you might be the only one at that moment that is using it. And also you are providing your own arbitrage. because no one is doing this infrastructure for you. So after you deploy this contract, in order there are some funds for the arbitrage to work with, you will have to deposit some tokens, WAVAX in the case of this lab, in the address in which this contract is deployed, and that will be the amount of the arbitrage. And then you set your own required funds to take that arbitrage, and that's the way that you are going to be able to take your funds back. If you messed it up, don't worry, because there is a withdrawable contract that we are inheriting here. Is a library. This will allow whoever deployed this contract to withdraw any token that is locked inside. So if your flash loan was not set correctly, or there's something there and you already sent some token amount to this contract, but the lab is not working, you are still fixing things and you need the funds back from the faucet or any other kind of tokens that you have sent to this contract, you can call the withdraw function, which is detailed here, with the token address of the token that you want to withdraw, and then the entire balance will be transferred to you. This is an only owner function, so it can only be triggered by the person who deployed this contract. So that's all for the mock arbitrage. Now let's go to check the flash loan. The flash loan is very simple. It's just contract that it's inheriting some basic functionality from AAVE. So let's start by the contract that it is inheriting from, which is flash loan receiver base. And this flash loan receiver base is very important, and it's very simple as well. What this contract is doing is creating two variables. One is called iLending pool address provider, which is an interface, and the other one is the lending pool. The address provider is the contract address that we are going to place when we create our flash loan contract. This address provider will populate this lending pool variable that is the one that we are going to be interacting with to provide us the loan. So this internally in AAVE is that they might change the addresses of the lending pools, but the address provider will always point us to the correct one. As you can see in the constructor, we have that we are inheriting flash loan receiver base, and we are placing the address provider address here. And we are going to check in the documentation that we are including in this repo where you can get this address provider depending on what you're doing. And then another variable that you need to pass is the address of your arbitrage contract. That is because this flash loan contract is going to be interacting with the mock arbitrage contract in order to provide you the arbitrage, right? The workflow, as you remember, is the flash loan will require the loan from the liquidity pool. It will take the arbitrage and then will return the loan to the liquidity pool. I will go to the main function first, which is the flash loan function. And as you can see here, in this function, you are able to send an array of assets and amounts that you want to loan. So you can flash loan several tokens in the same move, but that's not what we're going to do in our example. This is just the standard function as it's provided by the AAVE samples. You get these variables inside of the contract, who is going to be the receiver. In this case, this contract is the one that is initiating the operation and the receiver. If those are different, then the value of these variables might change, but that's a more complex scenario that we are not touching today. These memory params is also something that we're not touching today, and this referral code. Suffice to say that in this case, the receiver of the flash loan is our own contract, and the initiator is also our own contract. The for loop that you are seeing here is creating an array that is referring to what are the modes that we are going to include in our flash loans. And there are different modes, but the basic one is 0. There are modes where you have some commitment and you run some risk. Now, after this is set up, then this internal function flash loan is just calling the lending pool variable, and we are executing the flash loan function in that lending pool with the parameters of the receiver address, which is going to be this contract, the assets, which is the array that we are sending, the amounts, which is the array of amounts, the modes, which we just talked about, and who is the initiator, and the parameters and the referrer code. We have all of these automated in this contract where you don't have to actually touch this function for any reason. The function that we are going to create actually is this flash long. And this flash long function, which is the external one, is taking two parameters. One is the address of the asset that we want to flash long. In our case, we are going to do it with AVAX, and the amount that we are flash loaning. And these two parameters are then arranged in a way that they become arrays, so we can call the flash loan function internal that we have here with those parameters here. Very easy. We just have to submit what asset we want to flash loan and how much of that asset we want to flash loan. Afterwards, we have the execute operation. And this execute operation, which is an external function, is being called only by the lending pool. When the lending pool provides us with the flash loan, it's going to call this operation in our contract. And as you can see, what is happening in this operation is that it's passing certain parameters. What is the array of assets that the lending pool is lending us, the amounts, the premiums, which are calculated at the protocol level, and who was the initiator, and some parameters here that we might use for more complex scenarios, but we are not using those right now. Now, I will skip this part, but as you can see here in the end of the function, the lending pool is granting itself an approval for an allowance in our own balance on each of the assets that we borrow. And this is pretty interesting because this will allow the lending pool later to just pull the amounts that were borrowed from our balance, and then the flash loan will close the entire cycle. So basically this function is where we are allowing the lending pool to have the assets being returned. While we have the funds, which is between this moment and this moment, we can execute any logic. And here is where we are going to take our arbitrage. We are going to execute here the arbitrage contract, and we're going to execute the take arbitrage function. We can do that because we can create a contract object that then we initialize with the address of our arbitrage contract, and then this is what it's being executed. And we get our arbitrage, but then the lending pool is going to grant itself the necessary approvals on our allowance side of this contract to get their funds back. But we at that moment already have take our arbitrage, and the arbitrage amount is here in this contract. That's the reason this contract is also withdrawable. Then we have to come back and withdraw the amounts here. We should not leave any funds in our flash loan contract because there are certain attacks that someone can execute. And that's it for these contracts. Now we are going to go to deploy them. And the way to deploy them is very easy. We are going to go to our browser. We are going to go to Remix. And here in the contracts folder, we are going to click this icon. And here we are going to just upload all of the files in the folder that we downloaded from the repo, the Solidity folder. We have them there, and now we can compile them. So we can go to the mock arbitrage, we select it, and then here we can compile in this area. Compile mock arbitrage, we have it there. Then we can deploy. And for deploying is very easy. We want to deploy in the Fuji test network of Avalanche. So instead of this JavaScript environment, we're going to go injected web3. That will trigger our MetaMask and will ask us to approve being connected. Remix. And here we have our MetaMask connected. And I can see my address here. So I could just go here and deploy the contracts. mock arbitrage. Deploy here with the amount of funds that you want. Remember that these quantities here are in way, so you have to get some operation to convert them to actually integers of Ethereum compatible tokens. So that will be multiplying them by 10 to the 18. So that's it. Once you have deployed this one, you will have an address that will appear over here, and then you can go to deploy your other contract, my flash loan. So here, let's compile it. Let's deploy it here, flash loan demo. And here, as mentioned, you have to put the address of the address provider and the arbitrage contract. The arbitrage contract is the one that we just deployed, so that's pretty easy. But if I want to have the address provider, then I need to go to here and go to my references. And depending on what network you are working with, that will be the address provider that you need. So for here, I will choose the AAVE Fuji network. That will be this address provider. In Koban Ethereum is this one, and in Ethereum Mandate is this one. You will deploy with this one to actually get it deployed as in the lab. So that's all. After you have those data points, you can deploy your flash loan demo, and then you could start playing around with the contracts. Once you have deployed your contracts, and this is a neat trick, I could take the mock arbitrage, for example, which I deployed in this address, and I could go to Remix. And this is, let's say that you close Remix and you remember the addresses, but you don't want to redeploy, right? So what you would do in those cases is, I will have to return here to change to the mock arbitrage, and then you will just have to do @address, and that will bring you some interface to interact with the already deployed contract in the address that you have mentioned. So once you have your contracts deployed, we can go to check and create our UI. We're going to start reviewing the front end that we built, and all of the files for the front end are in this front end directory that we have over here. That's in the GitHub repo that we just downloaded. We have the index.html, which you can see here. It's just a collection of forms to interact with the mock arbitrage contract that, if you remember, is displaying what is the amount of the arbitrage that is available and the amount that you need to take it. Then we have the other section, which is about the flash loan. One is the section to execute the flash loan, which will offer us the field to input how much money we need to flash loan, and then the button to execute the function. This function is called flash loan. And then we have the function for clean the flash loan in this button that is called withdraw. It's a very simple UI. Then let's go to the logic, and here in the logic it's very simple. We just have our server URL and app ID from Moralis. This you get from your Moralis server, as you remember. Then we have the arbitrage token. This is the AVAX token for me, and this is going to be the one that's going to be hard coded in the repo. But remember that in references under important information, you have other tokens that you can use, specifically the wrap ETH for the Ethereum mainnet and for Koban testnet. So that's that one. For the flash loan contract address, this is going to be the one that you deployed. For the mock arbitrage, also the one that you deploy. And the ABIs are going to be hard coded here in this file. We have a simple login function, which is just getting the Moralis enabled Web3 to get all the Web3 environment going, and is switching the network to the hex value of the chain ID of the Avalanche Fuji testnet. Then we are executing this one, populate arbitrage. And this populate arbitrage is just executing two functions. One is getting the required amount and getting the arbitrage, and dividing those by 10 to the 18 because it's going to come in way, but we need it in the integer value of the unit. and that's something that we have around here: get required amount and get arbitrage amount. These are functions that are calling the mock arbitrage contract, and here it is. And we have the options of what is the function that we want to execute in that contract, and we need the AAVE. This one doesn't have parameters, and this is just using Moralis to allow us to send the transaction very fast and very easily. Now, when we have this one, we await the result, and then we're going to get what is the current required amount set up in the contract. For the get arbitrage amount, that's similar, but we are calling the ERC20 of the arbitrage token, and we are getting what is the balance of the mock arbitrage contract, because remember that the amount of the arbitrage, the actual amount that we can make, is the amount of tokens of that specific token that are deposited into that contract, which is just an ERC20 balance. So that's this one over here. Then we have the flash loan function, which works exactly the same, but we're calling the flash loan contract address with the flash loan function. We pass the correct parameters, and then Moralis is doing the heavyweight for us and getting a transaction receipt. For the withdraw, very similar to the previous one, is just calling the same contract, but with the withdraw function that we have established there. This is to get all the funds of a specific token out of the contract. So guys, this is everything for the UI. Now we're going to go to set up something that you are going to have to do yourself to set the environment for your lab. Let's get to it. To get our lab running, we need to run our UI. So we're going to set our Python server and start serving it. We are going to assume that you already changed the variables with your specific contracts. So we're going to go to front end directory. And here in the front end directory, we're going to run our Python server like this. Then we're going to go here and run that port in our server. And here we are. As you can see, the amount needed for taking the arbitrage in my contract is 100 WAVAX. And we have 0 arbitrage right now to gain because the arbitrage doesn't have any money right now if you just deploy the contracts. Now we are going to do the following. We are going to transfer some money to the mock arbitrage contract to set the scenario. Remember that this is a scenario only. So most likely you are not going to be the source of your own arbitrage, right? But this is just for means of practicing. So we're going to go back, and here in the remix, we already have the address of the arbitrage contract. So it's over here. We're going to copy that address, and we're going to go to our flash loan here. Not really necessary to go specifically there, but we need to provide our own arbitrage, and we're going to do it like this. We're going to assets, and in WAVAX, we're going to send some WAVAX to that contract. So here we're going to put here 5 WAVAX. Let's wait for MetaMask to get everything ready. We confirm it. Might take a while. We wait. Now it's confirmed. If we go to our assets, we have only 3 WAVAX. And right now, if we refresh this page, we have seen here this one changed to 5. So we need the 100 here to take that arbitrage that we just created ourselves. But this is just for practicing. Now, the next thing that we need to check is whether the liquidity pool in AAVE is able to lend us this 100, right? I let 100, close to 100 of liquidity there, but it really depends on what is the status of the pool. So let's check it out. And here is the liquidity pool. We're going to go to the markets, and we're going to go to Avalanche. And here we can see that this liquidity pool doesn't have a lot of money. So this is a little bit of a problem because it cannot lend us 100 right now. So we are going to have another lesson of DeFi, which is just depositing liquidity to a liquidity pool. So we're going to provide our own liquidity for this, but that's okay. We are going to define that for our own contract, we're going to need 15 of liquidity to be able to take the arbitrage. So we're going to go back to our remix here, and here we have already arbitrage contract, and we're going to have the set required funds changed to 15 WABAX. But remember that this is taking way, so we're going to do 15 and then 18 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. Let's set it up. We confirm. Our MetaMask will confirm that we really want to do this. We want to check when the transaction actually comes through. The transaction went through, so right now we can go back to our flash loan here and we can refresh it. And here we have it. So right now we only need a required amount of 15 to actually run this lab. These are values that you can set up before you do the lab. So that's what I did before when we were running this at the beginning of the video. I set this to 100 and I set my own arbitrage here. And I could take this arbitrage by myself because I have enough funds for that, but the fund thing is doing it through the flash loan, right? So what I will do is provide the liquidity pool with enough money to lend me. So I will go to the liquidity pool here in AAVE, and I will deposit more money to that liquidity pool. I will deposit 20. And I have already connected my MetaMask here. If you have not done it, then this is not going to appear, but it's very easy. It's just a connect with 3 button. So let's deposit. My MetaMask is kicking in, and I will transfer these 20 AVAX to the liquidity pool. It's going to become WAVAX at the moment that I deposit them. So here we have it. We have 20 WAVAX. So let's go back here to our flash loan environment. Here, if I go to check my MetaMask, right now I only have 6 AVAX, and obviously I don't have enough WAVAX. So if I try to execute the arbitrage by myself, the MetaMask is telling me that this is not coming through, which is expected. And now I can take the arbitrage indirectly by flash loaning this 15 to my flash loan contract, have my flash loan contract take the arbitrage, and then clean or withdraw all the funds from my flash loan contract. So let's do it. I will execute right now with this 15 amount. MetaMask kicking in. Here it is. Let's confirm it. And now to wait. It came through, so we have the transaction here. And we can copy this transaction. And we can go to a Snow Tracer to check the transaction itself here. And here we have it. We have the flash loan of 15 WAVAX from the liquidity pool to my flash loan contract. We have my flash loan contract take the 5 WAVAX from the mock arbitrage. This is internal to the AAVE protocol. And then we have my flash loan contract returning the 15 loan and the commission for the loan to the AAVE protocol. Perfect. Now that we have finished this part, we can go back to our flash loan contract, and if here we clean our dashboard, then we see that the arbitrage has disappeared. Now we can clean everything because the WAVAX is still in our flash loan contract and we want that WAVAX in our wallet. So we wait a bit for it to confirm. Here we have the transaction. And we can go right now to check our wallet, check how much WAVAX we have. And here we have all the WAVAX that we recovered. So guys, that's the way this works. It's always a best practice to put some coin of the one that you are going to flash long in your contract in order to have everything closed nicely. And in case there is some issue in the liquidity pool or in your arbitrage transaction and everything falls down and it doesn't execute correctly because of that, because the AAVE protocol will check if you have enough funds to pay for the loan. You could just pay for the flash loan with the amount of the arbitrage. That's totally possible. And actually, we go to my address here. You can see that what I got back from my flash loan contract is less than the arbitrage that the flash loan contract got. And that's because the flash loan commission itself was paid from this amount, because my flash loan contract didn't have any WAVAX at the moment that I execute the transaction. But let's say that this wouldn't have closed properly in my mock flash loan for some reason, then the transaction would have kind of reverted, and not necessarily because I set my flash loan wrongly. Maybe because the contract was not able to get any arbitrage from the transaction. If I run it right now, it's telling me here that the flash loan is not properly running. And this is because I don't have a way to pay for it right now, because there's no arbitrage here and this flash loan doesn't have any WAVAX token. And that's for the topic of this lab, by the way. Of course, when you are doing this for real, you have to check all the code, first thing of all, and then you have your own strategies on what you want to do. You might actually want everything to revert in certain conditions if certain things don't happen. I hope that you have enjoyed this lab, guys. I am Daniel, and thank you very much for your attention. Follow us in the Moralis channel. Smash that like button and subscribe to our channel. We have a lot more knowledge for you. Thank you. See you in our next video.